what we kind of do is we kind of let it manifest. But one of the things that kind of Neil brought up last week was this fingers of God situation that has been talked about, and I find it personally pretty interesting. And
I've never heard of that.
Welcome to the March 27th edition of the Electric View. I'm Neil Thompson. Today we got David, Buddy, Cameron, Heather, Jim, Peter, Richard, and Todd. We will be discussing the Redshift controversy and the fingers of God problem.
Yeah, could you go over it, Neil, a little bit?
Sure. It's a pretty damning situation. Basically, if you plot the redshifts of all the stars and all the galaxies and all the quasars, especially quasars, the Hubble constant no longer applies to them. Regularly, the Hubble constant indicates that the redshift is more or less on the same axis as brightness. So basically, you can see that there is a relationship between the brightness of a galaxy and the higher the redshift that it has. This is what's known as Hubble's law, or the Hubble constant. And
Well, wait. Are you assuming that redshift is a measure of distance?
I'm not assuming anything. That is the assumption that was especially with Hubble way back when. But when you start doing the same plot for quasars, obviously there's a problem. And so what happens is you end up getting these stretches, these lines that look like they're pointing towards the Earth. Like everything seems to be out of whack. And as you can see by just the image in front of you, that these lines, the Earth would be at the bottom of the triangle, at the very bottom there. And that's where we are.
No, what I'm asking is, these calculations that come up with these fingers, are those calculations assuming that redshift is a measure of distance?
Oh, of course, yes. That's what they're assuming, yes.
Okay, because in the EU model, it's not at all a measure of distance. So, well, I mean, redshift, yeah, has to do with distance, but quasars in the EU model are red because they're just being born. They're new. So those calculations are from the standard model, then, not from the EU model.
Of course. Yeah.
Right. It's just kind of.
I'm not arguing that.
It's a refutation.
So then, why would they be? I mean, why would the result be interesting if it's based on flawed assumptions?
Well, what we were talking about was the fact that they don't show it to anyone, that they hide this information, that it's not something that is commonly taught. It is one of those problems that if you learned it first, it immediately falsifies redshift equals.
Oh, I see. So you're saying that by not reporting that, they're covering up discrepancies in their model.
Yes.
Right.
Okay, that makes sense. So I get it. I get it.
And so when you start plotting these the redshift distances in the sky, you end up with two things that seem to happen. Number one, you get these weird fingers, so things look stretched out and pointing towards the Earth. And number two, you end up with what would be best described as concentric rings of quasars. So there is a stage where there are distances away from it. You will get a step and a bunch of quasars, and then further along you'll get another ring of quasars, and further along you get another ring of quasars, which would indicate two things: that there is a step-down motion, which Halton Arp seem to indicate as well, that it seems that they grow and that they mature in steps or stages, where they will be in this particular range, and then they will fall to this particular range, and so on, until they appear to be normal galaxies again. They mature, as you said, and I'm fine with that interpretation. In fact, it seems to me to be the only interpretation that could make sense of this type of data, because as you can see, we cannot be the center of the universe. The Earth did not explode and make everything around it. That's as Donald Scott might say, poppycock. So it's.
See that?
Pardon?
Does he use poppycock?
He's used poppycock and
Okay.
angel dust.
All right.
That's another good one too. I like.
Ooh, okay.
But you see, that's that information is a falsification that they know about. It's right there. I mean, you do the plot, and then they show you on the television this picture of the universe, and they remove all that data. Like all of the quasars are removed from the data, so it's just the galaxies themselves, and which of course seem to be relatively redshift equals distance e. Like it seems to be in that, very much a similar, like much more rational. So the idea of non-cosmological redshifts being HARP's big thing is so backed up by that data.
Very interesting.
Yeah. So they know it, and they obfuscate it, and I don't like that at all. I'm not a fan.
I don't know. It's like, okay, like take the thing with comets where they keep on saying they're dirty snowballs, even though every time they look at one, it's not. And I don't know. It's more like they see those things as anomalies. I would see more as a cognitive problem on their part than a cover-up. But that's just my
I mean, how do they handle? Yeah, how do they handle this when they this most recent trip to what was the most recent one where they had the probe? What was the name of it? I forget the name of it. But it was obvious that it wasn't a dirty snowball at all. But how do they from a standpoint of their position change their model? But
they don't change the model,
do they? Right.
They keep their model. Cognitively, it's almost impossible for them to give up the model. It's like they've accepted it as truth. And so then they say, oh, gee, we've got an anomaly here to figure out. They say they need to go back to the drawing board, but
they never do.
They never do.
They don't. But see, but that's a cognitive problem on their part rather than, let's cover this up. If they were going to do that, they said, well, let's not release the videos of the comet until we edit them, and they didn't do that. So anyway, I mean, it could be wrong, and it could be different in different cases. But I think in general, it's a problem of people being unable to see past what they see as truth.
Yeah, they have a. Well, let's just face it. If you were to challenge Newton and say that mass is somehow a force, or gravity or whatever is a force that can be varied, well, that's not something they're willing to accept, because everything they have is based off that, which, by the way, is such a powerful thing that even today, people whose opinion I respect greatly, for example, Robitaille, he's put out the liquid metallic hydrogen model. But that's only to account for the incredible lack of density of the sun. Otherwise, and I'm obviously a little more with the Donald Scott on this one, that any single body can be a star. It doesn't make any difference. If another large body entered, like way larger than the sun, entered into our solar system, besides the incredible crap that would occur, all of the electrons would start being processed by it, and the sun would go out. And I'm fine with that. If the sun was removed from our system, then Jupiter, Saturn, Uranus, and Neptune would begin to glow. And probably all the other planets as well would probably start to glow, because they have to process all these electrons. But it's
why do people emphasize electrons so much? I mean, a Birkeland current is as much ions moving as electrons moving. Electrons just move faster. See, it's not like in a wire, the metallic lattice
stays stable.
Stays stable, and then, of course, there's all this controversy about what current is. But the thing that is free to move to one extent or another is the electrons. But in a Birkeland current, both the both in a plasma, both the electrons and the ions are both moving at the rate dictated by the electrical field.
And their mass.
Yeah, and it's the positive ions coming into the sun which are causing all the discharge. So I don't know, I think people are identifying electricity with electrons too much in things I've heard.
Well, it's commonly done, yeah. But that's, you're right. It is a bit of a I wouldn't say misnomer. Electrons moving are not exactly electricity. In fact, the electric field being, EMF, and then the MMF, the magnetic field, and these magnetic motive force and the electromotive force and yada yada yada. They work. They are the fields that are pulling these things around, but they are themselves not actual particles. The fields themselves move a lot quicker than the actual particles.
Are you on the intersect list?
I don't know what that is.
Okay, well then we can't talk about that. I have seen discussion somewhere on back and forth. What is current, and how is it transmitted? And
there's a lot of discussion about that these days. Different ways of looking at it. There's something that strikes me just intuitively about just this particle nature of the electron forever that has always kind of sung untrue to me.
Well, I have a much better understanding of them now after talking with Edwin and understanding how they might not even be quote unquote real. They might be the reflection of a hole that has to be filled because of the shape of the protons themselves, and that they sort of come into existence because of that. But that's interesting. I don't know how true it is.
I mean, it's for me too. Yeah, I mean, Wan's model where it's kind of rarefication and compression. That one really sings to me pretty strongly. So.
And there's moments to be thinking that it might be. I mean, look at the idea of quasars themselves. What is causing the pressure to make, from the outside, like what is making this electron, what is making it come into existence when it is sort of, how much power will it have versus how much power how wide are the spacings? Because of the external pressure, what is right down. You're getting to the point of what is the nature of matter, and I'm.
Well, these are coming up.
Qualified to talk much on it,
Well, I'm wondering if. Oh, here we go. There's Peter. I'm wondering if Edwin's going to be able to make it today, but just this whole. Well, we should probably. That it's exciting what he's up to. I'll leave it at that, and in preparation for this conference. So, we'll. Would you agree, Neil?
Can I make a point about that? The ARP.
Yeah, absolutely.
Halton Arp was definitely the guy that did the most for observational evidence that the redshift distance thing couldn't be right. But his theory on that redshift is caused by the age of matter, that's absolutely not right. But he didn't have access to a lot of the work on like plasma redshift. And that's the one that's going to matter in quasars for sure. And that's the one that's going to explain why redshift is quantized too. And you remember that plasma redshift ideas is that it's actually the free electron density in the plasma that causes the redshift. And what happens in quasars is we have a huge ionization front, and that's what's causing the redshift. But the reason that comes on with such a bang, why you don't see kind of medium redshift quasars is because ionization fronts, when they happen, they just happen with a bang and they spread out like at light speeds. And this is what the Sapphire team found that in their little lab experiments too, that like when an ionization front forms in the lab, it's like overnight, it just spreads. You don't get a partial ionization front.
Is it like
examples?
Yeah. Is it like alignment? I mean, like dipole alignment suddenly. The ionization front. Yeah.
You get that charge separation, and then right as soon as that happens, you have all these free electrons, and that's what causes the passage of light through that, and that's basically the plasma redshift idea, and they play around with that in the lab. So like any laser optics guys know about that. They know that redshifts cause that way, and you can see too in those situations there's not, it's either ionization or not. I mean, you can see that in case of a simple fluorescent light bulb. You don't usually have a fluorescent light bulb half glowing, or it's either it's ionization or you don't, and that's what happens. That's why then you have that radical redshift at the ionization front at where the quasars are, basically.
Have you passed that by Don or Wall, or gotten any thoughts from them on that?
I think it's in Don's book.
But
I'm not.
No,
sure.
I mean, but I think Oh, are you saying that Don's already on board the way you look at it?
Well, I wouldn't be surprised. I recall reading something about Redshift.
No, I'm asking Jim.
No, I don't think Don really followed up the whole he knows that the mainstream model's wrong, but I don't think he's followed up the mechanism. Like, he's not a big plasma redshift guy as far as
Well, what about Wall? What about Wall? Is he? Does he just buy what Arp says, or has he seen what you're saying?
I'm not sure how far he is. Again, these guys, as much as they're experts, they got to be experts in those areas by being really focused on those things. Like, ask Don Scott about the Bessel function and all that, currents in space. But even those two, they're not even totally on board, or with, if Wall was still argue that magnetism doesn't play a role in planetary orbits, and Don Scott's work on the solar system hinges on that. They're not on the same page, even with each other, let alone.
I see.
But if you read up on plasma redshift, you get a good idea. Those ideas came up well before they were talked about, ironically, more in the Thunderbolts forum than ever by the big guys at Thunderbolts, and that's where I became aware of it, and I followed up the tangents from that. But you can see really clearly, and once you know that, that's where you see how that's where I got the idea that this redshift of satellites, when they fly by the Earth, that's how you can map out the electron densities up and down the current filament that the Earth is on. I mean, we know that there's current coming in or going out through the poles, so you would expect the electron densities to be greater there than offside, basically off out in the Earth's equatorial direction. And sure enough, there's plasma redshift in those directions, and the mainstream misinterprets that as actual Doppler shifts of the satellite. So they get these they measure anomalous velocity changes, but they're not. They're really just redshift changes, just because of the plasma right here around the Earth and where the electrons are. But once you get that was a key for some of the stuff I did with just mapping out filaments. You know where the electrons are, what they do. They cause they cause redshift, and that gives you an idea of when you're looking up or down a filament. You can go by the redshift, and even in the mainstream model, they see the this dipole in the cosmic microwave background. What they're really seeing is more of a redshift in the cosmic microwaves in one direction than the other, and that's really just because we are in this huge scale filament. When you look down the axis one way, you see a redshift. You look down the axis the other way, it's actually a little bit of a Blueshift, and they interpret that as not as velocity. In that case, they interpret that as a temperature difference, and that's why there's supposedly a warm and a cold lobe of the.
Okay. Now, do positive ions play any role in? I'm sorry. Do positive ions play any role in this, or is it just electrons?
It's the free electrons. I have to read up more on that too to see what. But I've only seen the treatment of the, how electrons interact with photons, not how ions do.
How do they determine that there's free electrons?
How do they determine that there are free electrons?
That they ascribe it to that.
Well, there's a lot of ways that you can measure electron density in plasma. Like besides the redshift would be a map, but then so are like radio scintillation screens. That's a mainstream term for really where the free electrons are, because
radio scintillation.
It just caught. Like if you're looking off in a direction, you see that. It's almost like the.
Well, besides wherever we know there's currents, we know there's electrons flying along.
Right.
The current itself is evidence of the presence of moving electrons.
Right, and that's why I was fascinated with the mainstream. When they see with current they see filamentary gas clouds, and they see radio scintillation screens traveling along with, they can actually map the movement of the free electrons. So they're measuring current. That's what it is, and that's where I get frustrated from time to time with the EU community, because all this data is out there, and as much as in the EU community they like bashing the mainstream has all the observations. They have all the equipment to do the observations, and they have all the raw data, but they just put it in terms of, like, you'll never see something on current flow, but you'll see the movement of radio scintillation screens, which they know are electrons. And if they see electrons flowing along filamentary gas clouds, that's current. That's current, and that's the way we think current flows too, is along these cylindrical shells on the surface, not like all down the core of these things. So basically, all the raw data's really out there.
I've thought along those same lines. The way I look at it is that we don't have a lot of money. The mainstream is doing all the research we would do if we had the money.
Exactly.
And then we get to look at the results and interpret it.
And then we interpret it differently, of course. Right?
Well, we learn, whereas they don't from their own work.
They got to fit it into the model that they have so much invested in.
I was just describing that, actually. That's exactly the problem as I see it. And I try very hard to make sure that the people whom are on the EU forums are not necessarily bashing for... I understand that there needs to be a little bit of chiding here and there, a little joke here and there, whatever. I'm fine. But when it comes right down to it, these people are providing all the data. We don't have giant telescopes. It's something that we need to use what they're talking about. And this is the same By the way, I did link that thing about Redshift. Donald Scott has a whole page on it. I just found, so I just linked it for you.
Okay.
But yeah, as I thought, it was in his book, Electric Sky. I remember reading it, so I was like, what's going on?
I think what he's got in Electric Sky is just that more on how the mainstream model is wrong. And Arp absolutely bashes the mainstream model. Now, his mistake was coming up with it wasn't a mistake. He proposed an idea, which turns out not to be right, though, that the whole idea that new matter is formed, ejected, and that's what a quasar is this newly formed matter. And then because it doesn't have enough time to interact with everything, it really doesn't even see the universe the same way as the old matter. It doesn't. It's not quite right, though. I mean, it's not right at all. But his observations are what's really important.
Yeah, they were pretty damning. NGC 7603.
See, Arp though was totally unaware of the ideas of plasma redshift, because mainstream astronomers in his day didn't have any of that. They were even worse with plasma physics when he made those discoveries than they are now, and he pretty much unaware of the redshift that you do get from a photon dispersing, not sparse. That's the key.
That was one of the issues that came up the other day. We were just talking about, because the shift itself is basically you're expecting a spectrum and then it's off. Is that correct? In my picture of it?
Right. Yeah. You know where to look for lines from.
Right.
Emission or absorbed lines.
Right. But the range of the range of those lines. Can you give me a little bit more of a elucidation on like how wide the spectrum is? Because we were kind of looking at it like the fringes of the visual. But
you mean like how?
Do they do? I mean, like if you go like, for instance, because I'm into this octave kind of view, my modality in my head. But if you go up 2 octaves from the visual spectrum, do they do measurements there? Like just outside, like double or triple the frequency of visual.
I don't know how far it. I mean, the reason it took them so long to even detect that that's what they were seeing in the first place is because there was such a radical shift in the lines. Like, what you have to remember too, like when we talk about it, like it's a really simple thing to look at these lines, but there's so many different lines, and if you had a set very much shifted and you didn't know to be looking for that in the beginning, then you'd be trying to interpret those as a whole different set of lines from some other element somewhere else. And it was quite a bit of pattern recognition just to see that, hey, this is the same set of lines from this, but all the way over here.
Right.
And
so once again, it's like if you have a hammer, everything becomes a nail, right?
Yeah.
I'm curious, where does gravitational lensing come in on the observation of these currents, if at all?
That's the other thing that the plasma does too. Is that's where Edward Dowdye's work is so important. He shows how plasma, like at the surface of the sun, bends light. But what it turns out is that when like the mainstream sees dark matter strings, and they think that they're bending light, but it's the same thing happening, that there are dark mode filaments in space, and you can see them by that bending of light, because those filaments also have those double layers, and they're going to do the same thing that happens at the surface of the sun. So that's really what they're seeing, is they're seeing these double layers of these filaments in space, and they do bend light. not by gravity doing that. That's
Okay.
It works exactly as Edward Dowdye says, but it works even on that scale.
Well, I mean,
Okay.
every star is powered by a dark mode Birkeland current, unless you actually have one that's not dark mode. So space is just filled with these dark Birkeland currents.
And light, yeah. There, I forget what I was listening to, but someone was talking about if you could reconstruct Laodicea and turn on make a model so that you could do the different modes of plasma. You could turn them on and see what it looks like, the glow modes, and then turn on the dark filaments, and you could see how they interloop and interlace and lead to the pattern, the Lichten flow like pattern that they seem to anode and cathode to, or but yeah, I mean, if we did that, I mean, because we found this filamenting network by studying gravitational lensing. So I've been very curious and hot on the trail of this pattern recognition of what is it that's warping this space that we keep observing. So what you're saying is just like what I was thinking, is that when we're looking at different angles of the tubes, the filaments, that's itself is bending the light, and we're seeing this everywhere.
Right.
Mm-hmm.
It's really nothing to do with mass change in gravity or change in the direction of light or anything like that. Markland convection will increase density on these filaments over and around other material around it. I'm not even sure if it requires double layers. It definitely requires refraction, according to Ed Dowdye, and of course, refraction is just optics. So what he said we should see, and one of the things we do see, is this propensity for blue-shifted or bluish Einstein rings. And the reason that they're bluish is because light, or blue light, will bend more than red light, if you get my meaning. So this is what this is just refraction, and it doesn't require any supernatural effects, the bending of space and time, or all that other kind of crap. It is matter of factly just density of material and light passing through it. And that's or more or less. There's probably some other aspects to it, but generally speaking.
Yeah, so, I mean, gravitational lensing, I mean, it doesn't exist, right? It's one of those mainstream fallacies.
In my opinion, and Dr. Ed Dowdye's, yeah, I would agree.
Okay.
And
okay.
What I emailed Juan a while ago. He's onto this topic now, but I showed him the similarities in gravitation. What we think is gravitational redshift. There's a couple patterns that come up as Einstein rings and Einstein crosses, and they're the same thing that we see. Like in the lab, you see ring patterns and you can see cross patterns, but when you get rings in the lab from like diffraction patterns, they're caused by spherical double layers or concentric spherical double layers. And when you see crosses, that they come from planar structures. So in other words, if the lensing in space we see is really caused by plasma, then we should see the same kind of patterns, because we know that there are spherical double layers like on the sun. We should see rings then caused by that, but we also have planes like the galactic plane. If you get any refraction from those or diffraction from those, you should see Einstein crosses from like where a filament crosses through a plane and that. And so in other words, we're seeing the same kind of pattern in the lab for like with crystals and lipids and different materials that you see in space. But in the lab, they know it's not gravity doing that. It's not gravitational forces causing, crystals to diffract light in one way, and bilayers in molecules to cause the rings. So that they know what's going on in the small scale, and it's going to be the same logic exactly in space. They're basically mapping out the charged double layers, whether they're spherical double layers or planar double layers. But it's all right there in the crosses and Einstein crosses and Einstein rings.
It's very interesting stuff, Jim.
Yeah. They always measure these in it's velocities that they're measuring. I mean, right?
Yep.
How do I visualize that like an intelligent person, which I don't claim to be?
Well,
that's attempted a joke too.
They just jump. They just jump right to the interpretation as, Redshift will move the lines one way or the other, blue towards the blue or the red end of the spectrum, and they interpret that directly as a Doppler
as speed. Yeah.
And then right there, all they do is measure how far a line is shifted, and they jump right to that's how many kilometers per second it's moving. Plus if it's blue shifted, minus if it's red shifted. And
but I mean, it's funny because they map it into a Cartesian space, but they label the axis as velocities.
Right.
Which for me is just there's a lot of cognitive dissonance in that. Yeah.